Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic center of gravity of symmetrical sections. Let's go to the numerical. An I section has the following dimensions in units. Bottom flange 300 into 100, top flange 150 into 50, web 300 into 50. Determine the position of center of gravity of the section. So, based upon the given data, I had drawn the I section diagram. This diagram is not given in the question. Based upon the data, we have to draw. Here, this I section consists of three rectangles. This one top flange, web, and then the bottom flange. Here, this reference videos for this numerical, such as an overview of center of gravity. In that video, you can get the formulas and the base concept of like such as area of the rectangle and other areas and the distances of center of gravity from the reference axis. That and all you can see. Then the x bar, y bar, even the z bar formulas in terms of mass, area, and also volume. Okay, that you can get in that reference video, that is center of gravity by moment method. The two videos, that means the reference videos, such as an overview of center of gravity and center of gravity by moment method. Both the video links I had given in the description box of this video. So just to go to the description box, we can find the video links of center of gravity by moment method and overview of center of gravity. That two links, that means that two videos or the reference videos for this numerical, it's better for better understanding. You just to watch that videos. Okay. Here, first the reference axis. Okay. We know that for y bar calculation, we will take the bottommost line as the reference. Okay. Then for x bar calculation, the leftmost line as the reference. Here you can see this I section is symmetry about its vertical axis. So it is not needed to calculate x bar separately, because we know that the center of gravity, it may be at any points on the vertical axis, but the center of gravity of the I section should lies on this vertical axis itself. Okay, so wherever the center of gravity, that means it may be anywhere in the central axis, that means it may be here, 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 wherever from the reference axis for the y bar, that value will vary. Okay, but the x bar value will not vary. Do you understand? Wherever the center of gravity, the distance between the reference axis of x bar, this one reference axis for x bar, this one the reference axis for y bar, this distance will be from this point. This is 300. So that divided by 2, it will be 150 mm. Okay. So from the leftmost line, we can take the x bar value equal to 150 mm. So we don't want to calculate the x bar value since it is symmetry about vertical axis. Okay. And first of all, this axis itself not needed. Okay. Then here we are going to calculate the value of y bar. Actually here there are three areas are there: the bottom flange, web, and then the top flange. The bottom flange, I am going to take the first rectangle, then the web portion, that is the second rectangle. The top flange, I am going to take the third rectangle. And here Everything is given in terms of rectangle, that means plane figures. So we will consider the areas of the segments. So A1 Y1 plus A2 Y2 plus A3 Y3 divided by A1 plus A2 plus A3. This is the value of Y bar. So to calculate Y bar for each rectangles, we have to calculate area and the distance of center of gravity from the bottommost line. That means the reference line. Okay. So here, first I am going to consider for the bottom flange. There is a rectangle 1. Okay. Bottom flange, which is the rectangle 1, the first diagram. Here you can see the area of the rectangle that equal to linear dimension multiplied with the vertical dimension. Here this one is 300 and the vertical value is 100. So 300 multiplied with 100. Okay. That will be 30,000 mm square. And here X value we are not going to find, only Y1. And this bottom flange, the bottommost line of the bottom flange lies on the reference line itself. So, and we know that in vertical value for rectangle, that means for any linear dimension, the center of gravity will be the dimension divided by 2. So from here means the CG1 that will be here. Okay. So that means 100 divided by 2. So 100 divided by 2. So we will get 50 mm. Then web portion, that is the rectangle 2. Here, first the area of the web portion. It has a 2 dimension. One is 300 and another one is 50. That means half of the previous value. 300 multiplied with 50. So we will get 15,000 mm square. Okay, 15,000 mm square. Then the value of Y2. The Y2 means here you can see this is the bottommost line of the second rectangle. From this point, okay, that means at the top point of the first rectangle to the center of gravity. This center of gravity will be 300 by 2, the distance. Okay, this will be CG2. Okay, so that will be 300 by 2. That means from this point. But we need from the reference, that is the bottommost line. So this 100 plus this 300 by 2. So we can take 100 from this point to this point. Okay, here to here 100 plus this distance, that is 300 by 2. So 100 plus 300 by 2. The 300 by 2, we know that 150 plus 100, you will get 250 mm. Okay. Then the top flange. That means the rectangle 3 as per the considered thing. Here, the value of A3 that equal to 150 multiplied with 50. So we will get 7,500 mm square. Okay. Then the value of Y3. Here you can see the Y3, that is half of the vertical dimension from this point. From here, the CG3 will be this point. That is 50 by 2. But this distance we need from the reference line. So from here, this one 100. After that 300. So up to this distance from the reference, 100 plus 300 plus 50 by 2. So we can take 400. That means from this point, that means the reference to this point. After that, the center of gravity value 50 by 2. So 400 plus 50 by 2, that will be 25. So we can write this value equal to 425 mm. So now all the values we have, substitute in the formula. Y bar equal A1 30,000 multiplied with Y1 50 plus A2 15,000 mm square multiplied with Y2 250 mm plus A3, that is 7,500 multiplied with Y3 425 mm divided by the addition of the three areas A1, A2, A3. Okay, we have to add. So 30,000 A1, A2 15,000, A3, that is 7,500. So if you add all the values, we will get the Y bar that equal to 160.7 mm. Okay, we calculated already X bar, that is 150 mm. Okay, so if it is the given area or volume, whatever, if it is symmetry about the vertical axis, we don't want to calculate X bar because that will be half of the distance from, or otherwise we can take the distance of axis from the leftmost line, that will be X bar. So here Y bar, we considered three different rectangles, then we calculated the value of Y bar. I hope you all understand this video. Okay, so don't forget to subscribe my YouTube channel Vishwaguru, a problem solver, for more number of videos on the topic center of gravity. Okay, thank you guys, thanks for watching.